Assalamualaikum warahmatullahi taala wabarakatuh. My name is Ainin Sofia. I will be explaining about the manual drill. Okay, for the assumption force, we put it as 150 Newton. The weight of the manual drill is 1.57 pounds, equivalent to 7 Newton, and the dimension of the manual is 6.3 inch or 160 millimeter in length, 14.57 inch or 370 millimeter in width, and then the 2.95 inch or 74.9 millimeter in height. The chuck size for the hand drill is 13 millimeter. The drill bit length is 1.57 inch or 40 millimeter. The maximum intensity equivalent to Q is 500 Newton or 500 Newton per millimeter. And the material for this hand drill is chrome vanadium. The drills have been in use for a long time. The early humans know that experience friction by torquing a wooden shaft could start a fire technique. It is still taught nowadays in survivalist camp. Archaeologists in Pakistan have found teeth showing that concentric marks of a flintstone drill, and the Chinese use the larger drill to extract water and oil from earth. The basic design for the manual drill that delivers torque to the drill bit has not changed, but the uses to make holes from the very small to the very large continues to grow. Then the internal torque for manual drill can be found by using a free body diagram. The FBD is explained by Ikmal, and I will be explaining for the distributed torque represented by the area of the trapezoid BCDE. And this observation can be used in drawing as a statically equivalent diagram. And then we calculate the maximum force that can apply to this manual drill in order to prevent from fail is 750 Newton. Since we estimated that we only apply 150 Newton to the drill, so it will not break the manual drill, and from the calculation also we obtain the factor of safety is 0.2 units.
Assalamualaikum warahmatullahi taala wabarakatuh, and good morning everyone. My name is Muhammad Ikmal bin Saari from Group C, and today I will discuss about free body diagram. The internal torque from our project, which is manual hand drill, can be found by using free body diagram. We make an imaginary cut for drill bit only. As we can see here, drill bit only. The distributed torque represented by the area of trapezoid B, C, D, and E. As we can see on the slide, the area of trapezoid B, C, D, and E. And this observation can be used in the drawing a statically equivalent diagram. Equilibrium then give us the value of the internal torque as before. From the calculation, we obtain the internal torque value is 7.5 Newton meter. We calculate the maximum force that we can apply to this manual hand drill in order to prevent from fail is 750 Newton. Since when we estimate, we can only apply 150 Newton to the drill, so it will not break the manual hand drill, and from the calculation, we also obtain the factor of safety is 0.2 units. That's all from me about our free body diagram, and thank you.
I want to present about safety precaution. What is safety precaution? Safety in the workplace begins with a proper safety plan that is put into place by management and observed by all employers. Safety precautions must be strictly adhered to because if they are not, some employers can put all other employers at risk. Next, workplace accidents translate into days missed for work. Reduce productivity and lost profit. If an employer is seriously injured, they must turn to works. Compensation which end up costing the business money in increased premiums. Also, morale among employers can suffer because they are concerned about their safety and ability to work in an environment where other employers have suffered an injury. A safety and health management plan begins with a proper assessment. A safety consultant should be hired to visit your workplace and take a visual and physically assessment from the point of view of the employer environments. From that assessment, the safety consultant can easily identify which area require a more in-depth risk assessment. In this project, we discuss about safety precaution when using manual hand drill. Firstly, always hold workpiece in a vise or clamp. Vise can be used for a wide variety of work. You need to select the most suitable vise, which is strong enough for the work. Secondly, use a correctly ground drill bit for the material being drilled. You need to wear safety eye protection while drilling. A tiny speck of dust in the eyes can feel like oversized clinker. It can cause temporary loss of vision and a great deal of discomfort and pain. Next, do not use a dull or cracked drill. Inspect the drill before using. Other than that, do not drill with too much pressure consequently. Might drive you to apply even more pressure to work or even break it then to quicken the drill process. Lastly, wear personal protection equipment like PPE while drilling. Drilling poses a number of physical hazards. Individual PPE provides protection from injury.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fitri bin Azmi, and I'm gonna explain about our calculation plan, which is what is our plan to calculate the structure. So first formula is about allowable shear stress, where shear stress is equal to Q times V divided by I times V. So Q is calculated statical moment, V is calculated shear at specific section, I is moment of inertia, B is width of beam at depth of specific section. And second formula is about maximum force that will fill the structure, and actually this formula is very helpful to determine whether our force that we apply into the structure will fill the structure or not. So the formula we will use is torsion maximum and forces maximum. Torsion maximum, when we get the value, we will insert to forces maximum, where torsion maximum is divided by R, which is outer radius. So next formula is about factor of safety. Okay, next we will go to the derivation for calculation. Actually to obtain all this equation, we do some web research and refer to our lecture note, and we get the differential equation is dt over dx plus q times x over l equal to 0, and it will be equation 1. So next, after we integrate the equation, we will get t is equal to negative q times with x square over 2l plus c, and it will be equation 3. So next, after we substitute equation 2 into equation 3, we will get the constant value of c. which is negative q times with x square over 2l plus c. It will be c equal to q times x square over 2l, and it will be equation 4. So after we substitute equation 4 to equation 3, we will obtain the formula we need, which is internal torque, which is T equal to Q over 2L times with L square minus X square, and it will be equation 5.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haziq bin Muhammad Shamsuddin, and my metric number is B0919104458. And today I will explain about the calculation and how do we get the value to calculate. So first we have to calculate about the internal torque. So for the formula to get internal torque is T equals to Q divided by 2L and bracket L power of 2 minus with X minus power of 2. So we assume that the Q is 500 and the length, which is L, is 0.04. So the X will divide it by 2 for the length and we will get 0.02. Then we will get the value for the internal torque, which is 7.5 Newton meter. Then to get the maximum force, we have to calculate the T max, which is shear stress. The T is the internal torque that we calculate earlier, which is 7.5. Then the X is 0.02. We divide it with J. So J, how do we get J? The formula is pi, we divide it with 2 and we times with C power of 4. So for C is the inner radius. We will assume that it is 0.01 and the value for J is 0.0157 micrometer. So after we get the J, we substitute into the shear stress formula, and we get the shear stress is 9.55 megameter. Then after we get the shear stress, we have to find the T max, which is the T max equal to shear stress times with J and divided with C. So where is the value that we get from the equation earlier, which is the T max is 9.55 megameter and the J is 0.0157 micrometer. Then the C is 0.01 that we assume. So we will get that T max is 15 Newton meter. Then after that we have to find the F max, which is the F max is the T max, we have to divide it with the outer radius, which is we have to times with 2 the inner radius, so we get 0.02. So calculate the F max, we get the 750 Newton. And lastly, I will explain about the factor of safety. So to find the factor of safety, we have to get F fill and divide it with F allow. So the F fill, we assume that it is 150. Then the F allow we we get from the F max, which is 750, and we divided it. So after we divided the F fill and F allow, we get 0.2 unit. So that's it for the explanation, and thank you.